We'll be continuing uh, on the second part of the exam review. So we have done like two of these questions, and I believe that should be good for us. We got into the graphing function, like the log functions or the exponential function that we can always go back to the nodes. So let's say 1 to 5 vertical asymptotes. Okay. Anyway, so we're going to continue on the second part of the exam review. So let me go over that. All right, so let's do question number 7. So this one's kind of tricky. Then we're going to combine them as well. So now we're going to have like log 2, right? You're going to combine into a single log, correct? So you may end up with like log 2 of x minus 3. I'm sorry, x plus 3 times x minus 3. I'm sorry. They're going to have this equal to 3. Uh, I'm sorry, it should be divided because those terms division. So we're gonna have like x plus 3 and then over x minus 3 and equal to 3. And now you're gonna move 2 to the right. All right. So we're gonna keep the whole thing equal to 2 to the third. And then so that would be 8. And then we can multiply both sides by x minus 3. And then you can, just get rid of this. And then you're gonna have like x plus 3 equal to ax minus 24. Then we can solve for that. So we can have like 7x equal to 27. So therefore x equal to 27 over 7. Okay. Well, this is not too bad. We simply have to like combine them into a single log and then move the base to the right, and then I'm going to simplify the terms. Any question? All right, so let's do question 6. So that is a very important question. So you're definitely going to see this question on the exam. So very important. All right, so the first thing we have to do, we're going to take the ln both sides. So the ln of 2 to the power x plus 1 equal to um, ln of 3 to the power 2 minus x. And then afterward, we're going to move the base to the front. I'm sorry, move the exponent to the front. So that becomes x plus 1 and 2 minus x times ln 2 equal to 2 minus x times ln 2 times ln 3, I'm sorry. All right, and then we have to combine them, right? You're gonna expand this. So once we expand those terms, we're gonna get x times ln 2 plus ln 2 equal to 2 ln 3 minus x ln 3. So the next thing we have to do, we're going to combine the x terms, correct? We're going to combine the x terms. Left, constant, right. So we're going to move the x ln 3 to the left. So we're going to plus x ln 3 both sides. All right. So, but we also move the values to the right. I'm going to subtract ln 2. So by doing so, we're gonna get rid of the uh this and this. Subtract ln 2. I'm sorry, it's not ln 3. So I'm gonna get rid of this and this. And I'm gonna factor out the x. So we're gonna get x times ln 2 plus ln 3 equal to 2 ln 3 minus ln 2. And finally, you're going to divide both sides by ln 2 plus ln 3. You finish. All right, guys. So what is the hardest part of this question? The hardest part is you need to isolate the, the ln terms and the x terms, right? And then factor the x out, and then we divide it, and then you combine them into the ln terms. So on the exam, we should have like four ln's, the top two, and then the bottom two. Okay, so that's pretty much it. Are we good? Any question? All right. I feel like that's pretty much it. So most of this question 10, 12, like 15, 16, we did it last Wednesday. Also question number 9 as well. We did that. Make sure you go over those questions on the exams. 1 and 2 is very similar question that we did. So 9, 10, 12, 15, and 16 are done on last Wednesday, right? Which is on 26. Please review the notes. Are we good? The only question that we haven't done was question number uh 14. So let's do it again. All right. So the initial population uh was 300, right? So we call it P0. And then so this can be computed by equal to 300. It's gonna decay like 10% each hour. So decay 10% each hour. So we're gonna get R equal to zero point 0.1, right? So you want to find the amount of drug that would remain in the body after 24 hours. So T gonna be 24. All right. So you're gonna figure out the P of 24 based on the initial population. So we're gonna take like 300 times e to the power, like zero point 0.9 is raised to the power 24. Okay. So we're gonna do it on a calculator. Let's see how it goes. So we're gonna take, uh, you know, 500 times zero point 0.9 is raised to the power 24. We got 39.8 grams. Are we good? The solution that I have was like it's kind of messy. Like somehow when I put down the answers, somehow I forgot to check. It's not on the domain and you can omit it because you know, it's kind of different. We also remove like the compounding interest rate, even if it, it will not be on the exam. It might be on the final exam. We're gonna cover that after the second exams. And so we're gonna fight T in terms of the form, so it's kind of different from what we have. This one, the exponential function. So in terms of exponential function, we have like a a equal to p0 times e to the power rt, something like that. I actually used different syntax for this question. The k was zero point 0.1, and then the t was 24. So we can have this. We'll take 500 times e to the power negative zero point 0.1 times 24. So that's going to be 500 times e to the power negative 2.4. Okay. So when you plug that into the calculator, we should get something like this. It should be slightly more than 39.8, less than 39.8, or small, it's really 45.3. So this one is sort of different. Excuse me. Uh, we actually learned for the compute, the continuous model, so you get 45.3 frames. Okay. For the half-life that we have learned is simply like how long it takes uh, to uh, decrease the initial population. Half. So we started using a formula that we have would be 8 equal to P0 times two to the power negative T over T half. So so we need to figure it out like what it is. So for the initial populations that we can, I mean, we can use the form that we have established, or we can also, use the form that we basically I showed you guys, which is negative ln2 over k, whatever you want to, and then we can figure it out, relatively easy. So for the half-life forms, it's going to be equal to negative ln2 over over the constant, which is k. We plug that in. So we take negative ln2 over uh, 0.1. They're going to plug that into the calculator. We should be able to get to the final answers. So negative ln2 over 0.1. So we have the answers negative uh, 6.9 something. So that takes about like 7 years. Okay, so to decrease the amount into half, so 7 hours, I'm sorry, 7 hours. You have um, the initial population. All right, I feel like that's pretty much it. So this question was just simply uniform, right? I think I'll refer you guys to the notes that we had before the spring break. It was on um, it was on it was on the lecture notes. Yeah, so you can also review those, and then you can figure it out what it is. It wouldn't be that bad on the exam. Simply what we have here, the half-life just you know, I use Ramder, but for some reason, I've note we're using K to represent the increase or decrease. In terms of the half-life, so this one is supposed to be negative. I would recommend you guys to look back to the lecture 5 on March 12th. So it's supposed to be very important to figure it out. Okay, so it just let you know. All right. I feel like that's pretty much for today. Any questions, any concern? If there's no questions, I will end the lecture notes today. Make sure you're going to go over all of these questions plus you should know how to we should know how to like compose or decompose the log function because of the log terms because that's also beyond the exam. We should know how to sketch the log function. We should know how to sketch the exponential function And those are critically important, to solve the log equation. Are we good? Oh, we also we need to know how to find the coordinates on a circle with the radius r, and then the angle was 3 pi over 4. You should know how to find the area or the arc length of a circle based on the the angle and the radius. And we should know to solve the equation. If the question gives like one side length, one angle, we just have to do like one equation, like using SOHCAHTOA. If the question gives us two angle and one side length, then we have to using most likely you have to use a tangent or cosine. I don't know. It depends on whether it gives us the hypotenuse or what we're looking for. You have to look for the adjacents, hypotenuse, or hypotenuse opposites, right? All of this, you just need to understand the rules along the way. All right. If no more question, then we'll just end the class here, and then we'll see you guys on Wednesday. Remember, the exam's gonna be, like 2 hours. Make sure that we are going to, arrive early, and make sure that you're gonna take a page of notes. So front and back should be good. And then you're going to skip two questions that you don't have to go over to review, 11 and 13. And don't forget to go back to the answer key as well. Make sure that we understand what it means, how to combine the logs, how to decompose the log terms, ln terms. The exam will be very similar to that. We're not going to do question number 12. I'm sorry, question number 13, but we have to do question number 12. I think we did all of this on the test. I'm sorry, on the last Wednesday. All right, guys. So I will see you next so this Wednesday, and make sure that we are right on time to take the exam. So have a wonderful day. Take care.